Last time we actually met a really big idea doing the project. The project was called Carly's Clippers, and we had 3 different lists. The hairstyles which we have on offer, like a mohawk, the prices for them, and how many we sold last week. And we worked out various things like the revenue and the average revenue. We could do that by taking the total revenue and dividing by 7. Remember that? Averaging the revenue. But what really got us last time was task 12, I think it was, where we had to use a for in loop. And we ended up doing silly things like we had a for in loop with a condition. So it was a list comprehension involving a loop. But at the end there was an if statement, and we said if I is bigger than 30, and we got an error for that. You can't do that. You can't have a comparison operator between an integer and a number. You can't have I and 30 compared. They're just not the same data type. What we needed to do was use an index expression. So we had to say if hairstyle I is bigger than 30. That we can do, because we were or less than 30. Remember, because we were only interested in the cheap haircuts. The other thing, and this is the big idea I talked about, was that we didn't just have it was this idea of a sort of compound temporary variable. So we're very familiar with the idea of having just a simple temporary variable. For example, style, or hairstyle. So I could say do a for in loop, and you'd say for hairstyle in hairstyles. Okay, we're all familiar with that. But the solution, if you remember it with Carly's Clippers, it actually involves saying for style, I in hairstyles. So we had this compound temporary variable, style, I, both style and I, in the temporary variable. The other thing we saw was that when we didn't just name a collection, we didn't just say for X in hairstyles, where hairstyles is the name of the collection. What we did was say enumerate function applied to hairstyles. So we said enumerate open bracket hairstyles. So hairstyles passed in is the bracket. Let's continue. And we needed the enumerate function because we weren't just interested in the elements in hairstyles, but also their position. So that was a sort of a massive learning point there, a big lesson to learn. That for in loop in the list comprehension, it had a compound temporary variable, and we used the enumerate function. Introduction to functions. Why functions? Let's come back to the trip planning application we just discussed in the previous exercise. I'm not sure about that, but I don't remember that trip planning application, but anyway. The steps we talked about for our program were 1, actually let's go back. Right, okay, it skipped right over this. Okay, I don't know why it went to 2 straight away. Let's just work out how to use everything. Yeah, so we finished Carly's Clippers. If I go back to syllabus, because I don't want to do the project again. Functions, right. Oh no. Oh. Let's go back. So this is a good time to learn. I've got to know how to navigate. So I'm doing the course. So that's the overall entity. It's called a course, and it's called Learn Python 3. And it tells us that our current module is functions. So the course is made up of modules. If I say view syllabus, and you can see that it tells us your current module is functions. 1 lesson, there's a quiz to do, 2 articles and 1 project. So we need to go to the lesson, don't we? So I click on lesson called Introduction to Functions. Perfect. So why here? Okay, here we go. And it's gone to 2 again, 2 out of 13. Okay, Introduction to Functions. In programming, as we start to write bigger and more complex programs, one thing we start to notice is we will often have to repeat the same set of steps in many different places in our program. Let's imagine we were building an application to help people plan trips. When using a trip planning application, we can say a simple procedure could look like this. 1. Establish your origin and destination, so the endpoints. 2. Calculate the route between them. And 3. Calculate the best route to the user, or return the best route to the user. Actually, 2 is not necessarily, they say calculate the distance. We will perform these 3 steps every time users have to travel between 2 points using our trip application. In our programs, we could rewrite the same procedures over and over for each time we want to travel. But there's a better way. Python gives us a useful concept called functions. Functions are a convenient way to group our code into reusable blocks. A function contains a sequence of steps that can be performed repeatedly throughout a program without having to repeat the process of writing the same code again. In this lesson, we are going to explore the idea of a function by slowly building out a Python program for our trip planning steps. At the end of this lesson, you'll know how to write a function and return values from it, allow functions to take custom input, and you'll know how to experiment with how functions access our other Python code, and much more. Okay. So you get the basic idea there, functions let us do kind of package into one place things that we'd otherwise have to do over and over again, so we just return to the function. They're a convenient way to group our code. This is this idea of grouping our code into reusable blocks. Right, what I want to focus on really in the lessons and projects that come is the question of how do you start to really, we all know that, that's good, that's nice, we can all appreciate the theory, but how do you start thinking that way? How do you actually get into that headspace? Right, because I can imagine you can, click, you've done the module on functions, but are you actually, if you were to write code just on your own, would it occur to you to write functions? So are you really going to be affected by what you've read here? Really? That's the real hard task. So that's what I want to think about, and if you're following, I think you should think about too. How, try to think, how would I even get to the point where I'm thinking, can I function this every time I write code? It happens with comments too. Like, you can read, you've got to keep your code readable by putting comments in it, and you read it and you tick it and you say, yes, I've understood, and you sort of do understand. But then you write code and you just don't put comments in. It didn't really affect you. So how can I be persuaded to really actually be such a person that having finished this module, I go out and think in terms of functions? Can it apply to other parts of life? Okay. Instructions. Review the visual for the function called navigation steps. Okay, so because it's a function, we write it with to show that it does take things in. So we put those blanked out rounded brackets. Notice how the function navigation steps serves as a container for the 3 steps in the procedure, and can be reused across multiple users as they plan their trips to different locations. Click Next when you're ready to learn more about functions. So let's look at this animation. It says it's called navigation steps. 1, establish your starting and end points. 2, calculate the distance or route. That's a bit confusing. Is it the distance or the route? Because I'm sure that you can have 2 routes which are the same distance. Route is the manner in which you move from one place to another. Distance is just a scalar value, isn't it? Route is a shape of it's a line. No, not a straight line necessarily, but a series of points between a set of points between 2 points, the start point and the end point. 3, return the best route. And of course, I'm sure they're going to say, well, what do we mean by best? Is a route better if it's a shorter distance? Sometimes people might consider a route to be better, even though it is actually a longer distance, but perhaps they're able to use the motorway on that route so they can drive faster. Perhaps they go a scenic way. Okay, next. Why functions? Let's come back to the trip planning application we just discussed in the previous exercise. The steps we talked about for our program were: 1, establish those points, the origin point and the destination point. 2, calculate the distance /route. And 3, calculate the best route. If we were to convert our steps into Python code, a very simple version that plans a trip between 2 popular New York tourist destinations might look like this. Print, setting the Empire State Building as the starting point and Times Square as our destination. Print, calculating the total distance between our points. Print, the best route is by train and will take approximately 10 minutes. Anytime we want to go between these 2 points, we would need to run these 3 print statements. For now, we can assume the best route and time will stay the same. I think what they're trying to say there is that the best route is the best time, the shortest route in terms of time. If our program now had 100 people trying to find the best directions between the Empire State Building and Times Square, we would need to run each of our 3 print statements 100 times. Now, if you're thinking about using a loop here, your intuition would be totally right. Unfortunately, we won't always be travelling between the same 2 locations, which means a loop won't be as effective when we want to customize a trip. We will address this in the upcoming sections. For now, let's gain an appreciation for functions. Instructions. 1. Run the pre-written print statements to see what they output. So let's have a look at the console here. So we've got a comment: first user wants to travel between these 2 points, and then a print statement setting the Empire State Building as the starting point and Times Square as our destination. We've got a second print statement calculating the total distance between our points, and a third print statement: the best route is by train. Here's a comment: second user wants to travel between these 2 points, third user wants to travel between these 2 points, fourth user wants to travel between these 2 points. So let's run, and of course we've got our 3 statements printed out. Step 2. Write the same set of print statements 3 more times. Run the code again and see the output. Three more times, really? The same set 3 more times. 1, 2, 3. Okay, did you print out the exact same set of 3 print statements from the first step 3 more times? Yes, I did. I'll click View Solution. What's changed? Here they have 1 line between Times Square as our destination and calculating the total distance, and in their recommended code they have 1 line between Times Square as our destination. Oh, I'm supposed to put them in with the comments. Okay, is that it? So I'm going to just reset the workspace, click run. So that's step 1. I think it wants me to paste, so second time, put them in the comment sections, and after fourth user wants to travel between these 2 points, paste, run. Okay, we've got a tick now. 3. Hopefully now you have some perspective about your life without functions. In the next section, we will learn how we can refactor. Really important word, refactor. Make a big thing of this in AWS. It's not re-architect, not re-host, not re-platform. No, refactor. Refactor, meaning if you think about factors with numbers, they're there's more than one way to factorize a number. They're the internal components that when multiplied together make up the number. So factors of 10 include 2 and 5, because 2 multiplied by 5 is 10, but also 1 and 10. So there are ways of making up the thing. So we'll learn how we can refactor our code to utilize functions to reuse code. Click Run your code again, and then click Next to continue. Okay, run, next. Defining a function. A function consists of many parts, so let's first get familiar with its core, a function definition. Here's an example of a function definition. Def, function space, function name, colon, and then the function tasks go here. There are some key components we want to note here. The def keyword indicates the beginning of a function, also known as a function header. The function header is followed by a name in snake case format that describes the task the function performs. It's best practice to give your functions a descriptive yet concise name. Following the function name is a pair of parentheses rounded brackets that can hold input values known as parameters. More on parameters later in the session. In this example function, we have no parameters. I would say although they are parameters, because the main thing to tell a student is that the things which go here are arguments. Things that are fed as inputs, then they're processed so that we can have a particular output. Think of a black box. You feed something in, something comes out. That's what a function is. Now, the concept of a parameter is some value that takes different values in different cases. Some constant, not always a something that takes different values in different cases. Now, it's true. The arguments, the things we feed in, are parameters because they can change depending on what you want the argument to be. But I think it's more important to say they're arguments. You've got a colon, dot dot, to mark the end of the function header. Okay, so here, we have the function name and then dot dot. Lastly, we have one or more valid Python statements that make up the function body, what's called the function body, where we have our Python comment. You can see they've just put a comment here. That's where the body goes. Notice we've indented our comment. Like loops and conditionals, code inside a function must be indented to show that they are part of the function. Here is an example of a function that greets a user for our trip planning application. Def trip welcome, colon, print welcome to Trip Academy, print let's get you to your destination. So just 2 print statements making up the body of this defined function. Note, pasting this code into the editor and clicking run will result in an empty output terminal. The print statements within the function will not execute since our function hasn't been used. We will explore this further in the next exercise. For now, let's practice defining a function. So if I copy that and paste it here and click run, we've got print statements, but they're part of a function and we're not calling the function. We're not doing, there's nothing you should expect from that in the output. Instructions. 1. Two of the most common NYC attractions include the Empire State Building and Times Square. In travel.py, we'll write a function that prints the directions via subway from the Empire State Building to Times Square. First, define a function called directions to Times Square. Leave the body of the function empty for now. Def directions to times SQ, and then put rounded brackets, and I'm going to put a colon. Note, when we run the code, we will see an error, which is syntax error, unexpected EOF while parsing. This will occur when we don't populate a function with any statements. We will populate it with code in the next step. EOF stands for end of file. Python is telling you that it was expecting some code in the body of the function, but it hit the end of the file first. So if I click run, you can see we do have this red text saying the file at this path, intro to functions /travel.py. It's on line 2, indentation error, expected an indented block after the function definition on line 2, which is fair enough. 2. Within the body of the function, use 3 print statements to output the following directions. Walk 4 minutes to 34th St. Harold's Square train station, take the northbound NQ, R or W train, 1 stop, and then get off the Times Square 42nd Street stop. So I'm going to copy that to clipboard, paste it here, and make them into print functions. So I'm going to write print and then opening rounded bracket, and I'm going to use that once, twice, 3 times, and add the closing rounded bracket or parenthesis. Remember, if you run your code, you shouldn't see any output in the terminal at this point. Check out the hint if you want to see the output. So run. No speech marks. Calling a function. Now that we've practiced defining a function, let's learn about calling a function to execute the code within its body. The process of executing the code inside the body of a function is known as calling it. This is also known as executing a function. To call a function in Python, type out its name, followed by parentheses. Let's revisit our directions to Times Square function. So we had def and 3 print statements within it. To call our function, we must type out the function's name, followed by a pair of parentheses and no indentation. Simple as that. Look at that. Just type out the name, the thing we put after def. So directions to underscore times SQ and then rounded brackets. That's it. You're calling it, you're naming it, you're invoking it. Calling the function will execute the print statements within the body, from the top statement to the bottom statement, and result in the following output. Finally, some output. And it's the three strings. Walk 4 minutes to 34th St. Herald Square train station. Take the northbound NQR or W train one stop and get off Times Square 42nd Street stop. Note that you can only call a function after it has been defined in your code. Now it's your turn to call a function. 1. Call the directions to Times Square function. Click run to see it execute and print out. We've got the output. And a tick there now. 2. Add an additional print statement to our directions to Times Square function. Have the statement print, take lots of pictures, ! Run your code again and see how your output changes. So I'm going to go to the, not where I call the function, where I mention it by name, but where I define the function, and add in to the body, print, take lots of pictures. I command you, run, and now we get that in the output. And a tick on number 2. White space and execution flow. Consider our welcome function for our trip planning application. So this is what we mean by our welcome function. We have a definition, def trip welcome, so we're defining a function called trip welcome, and it has 2 print statements. Welcome to Trip Academy, let's get you to your destination. The print statements all run together when trip welcome is called. This is because they have the same base level of indentation. 2 spaces. In Python, the amount of white space tells the computer what is part of a function and what is not part of that function. If we wanted to write another statement outside of trip welcome, we would have to unindent the new line. So move it further to the left. Think about it. Indenting is moving it inwards to the right of the page, so unindenting it. So here we have trip welcome, welcome to trip, let's get you on your destination, which we've already seen, and they've said as a comment the indented code is part of the function, but the unindented code below is not part of the function body. So we have a print statement, and this is a new statement saying, whoa, look at the weather outside, don't walk, take the train. And then there's a line calling the function, which is defined up here, trip welcome, trip welcome. Our trip welcome function steps will not print, whoa, look at the weather, on our function call. The print statement was unindented. This print statement, the whoa, it was unindented to show it was not a part of the function body, but rather a separate statement. We would see the following output from the program. Whoa, look at the weather outside, don't walk, take the train. Then, welcome to Trip Academy, let's get you to your destination. So notice how welcome to Trip Academy is actually higher up. You know, if we just look at it as lines and don't pay any attention to the keywords, welcome to Trip Academy actually occurs here before this line which says, whoa, look at the weather outside. So welcome and then whoa. So why do we have whoa and then welcome? Well, because welcome is part of the function, and we call the function later after printing whoa. So lastly, note that the execution of a program always begins on the first line. The code is then executed one line at a time from top to bottom. This is known as execution flow, and is the order a program in Python executes code. Whoa, look at the what was printed before the print statements from the function trip welcome. Even though our function was defined before our lone print statement, we didn't call our function until after. Let's play around with the indentation and the flow of execution. 1. We're going to help our trip planner users figure out if they should travel today based on the weather. Let's let our users know we can check the weather for them. Write a print statement that will output checking the weather for you. Okay. Print. And remember the speech marks. And also, if you're ever going to do an F string, remember that little F, the lowercase f, before the opening speech mark. Last session we kept forgetting that. So, checking the weather. I'm doing it. I'm in the process. I'm checking the weather for you, exclamation mark. Run. Tick on 1. 2. We took a look outside and see a bright, sunny day. Write a function called weatherCheck that will print a message to our users that it's a great day to travel. The function should output looks great outside. Enjoy your trip. So def, and then just space. This is what, if you're really new to Python, you kind of might worry about these spaces. It's very, again, quite blunt. You know, if I did def and then started typing function name, obviously that is a mistake. So the space is important. Def. It's the same with, you wonder with arithmetic, can I put 6 and 7 as well as 6 space? The 7 is the one that's better than the other. So space, then the name of your function. So it should be called weather_check. Show that it can take things in. So put a shape there that can take arguments in. Put the parentheses. A colon. Next line, and I can see it's already indented my flashing cursor. And we want to print speech marks, looks great outside, exclamation mark, enjoy your trip, full stop. No, don't call your function just yet. We'll do that in the next step. So run. We've got a tick on 2. We've done what's required. It hasn't printed looks great outside because we haven't called the function, we haven't invoked it, we've kind of loaded it up. 3. Oh no, it looks like some clouds came in and it started raining. Okay. And think about this, we've just loaded up a function with looks great outside, enjoy your trip. It looks like some clouds came in and it started raining. Our users shouldn't go on a trip in the rain. In our weatherCheck function, add a second print statement under the first one, which prints a warning message for our travellers. It should print, false alarm, the weather changed, there is a thunderstorm approaching, cancel your plans and stay inside. So I'm obviously going to copy that, because it's so long. Print, opening speech mark, paste in, Control V. So now we've got 2 print statements saying different things. We obviously wouldn't want both of them to be printed because they are incompatible. There's a sense in which they're contradictory because it can't both look great. We can't be advising them to enjoy their trip and cancel their plans. Same level of indentation. So we're going to have to do something here to modify that. 4. Call the function weatherCheck. Okay, I'll just follow the instructions. Just type it out. WeatherCheck. Whoops. Weather_check. And that's it. Just plonk it there. Run. And now we've got those 2 contradictory statements. Looks great. Cancel your plans. Okay. 5. Unindent the final print statement, the one starting with false alarm, in your weatherCheck function. So unindent it. So I'm going to take it, unindent. So remove it from being injogged. And I'm actually going to just, to make it easier, no. So I'm going to leave it with no line break, because just to make the point that even though they look like they're next to each other and it looks like it's part of this block, the indentation is sufficient to separate this print statement from that print statement, and indeed from the function. So hopefully when I click run this time, because of that unindentationing of the false alarm statement, we won't get this false alarm in the output. So here we go, run. Oh dear. Oh dear. So it did get printed, but not because it was part of the function. Okay. So we're still printing it. You forgot that we're still printing it. We're still printing it, but not because it's part of the function. So yeah, it is separate from the function. What's changed, you'll notice in the output, is that the order has changed. We call weather check, which includes looks great outside last. So we get looks great outside as the last statement. Even though we say looks great, look, if you look at the code, we actually say looks great outside, then the next line is false alarm. So it should be the false alarm thing, if you think that that's all that matters, coming later, but it isn't, because we call the function later. Okay. Next. Parameters and arguments. So if I look up parameter in my dictionary, it's got a really nice way of defining it. This 1964 dictionary. The concept seems to be the same. A parameter is, does it say I think it uses the word quantity. That's it. I was thinking, I said constant before and value, but really you want to say quantity. Here we go. So it's a quantity constant in the case considered. It's great alliteration. A quantity constant in the case considered, but varying in different cases. That's the concept of a parameter. A quantity constant in the case considered, but varying in different cases. Let's return to our trip welcome function. One more time. Let's modify our function to give a welcome that's a bit more detailed. Take a look at this code. So we've got the definition of a function, we've got one print statement and a second print statement. And then we call the function. And this will output, welcome to Trip Academy, looks like you're going to Times Square today. Our function does a really good job of welcoming anyone who is travelling to Times Square, but a really poor job if they are going anywhere else. In order for us to make our function a bit more dynamic, we're going to use the concept of function parameters. Function parameters allow our function to accept data as an input value. We list the parameters a function takes as input between the parentheses of a function. Here is a function that defines a single parameter. So in the definition we say single parameter. We're kind of saying, look, you can put this single parameter here. We're naming it, we're stating it. In the context of our trip welcome function, it would look like this. Trip welcome, and then we'll write destination in the rounded brackets. And then our print statement can actually be, looks like you're going to, and then destination. And we write destination to go and grab the whatever they've put for destination today. So we've got this good old concatenation, we've got this mixture of a string, just a variable, and a string. In the above example, we define a single parameter. It is a quantity. I suppose Is it a quantity here? I mean, perhaps you could argue that strictly speaking it is. I mean, these are just... it's a word. It's certainly a value. But, I'm sure that this display that we see, which is this sequence of letters, they write Chicago or New Orleans or I don't know, whatever. No, should probably name somewhere in New York. But what is a word? It's probably ultimately encoded in numbers. So it probably, strictly speaking, is a quantity. So what the user is specifying when they specify a word is a quantity. So perhaps our definition does still stand. A parameter is a quantity constant in the case considered, but varying in different cases. And you can see that that's built in. We know that some people there'll be some cases where people have one destination, other cases where people have another destination, so it's varying in different cases. But at the same time, we want it to be fixed for the whole duration of a single individual's interaction. So if I say, well, my destination is Brooklyn, I do want you to keep that constant when you tell me, looks like you're going to somewhere. I want you to say Brooklyn. So we want that constancy within the scope of something. In the above example, we define a single parameter called destination and apply it in our function body in the second print statement. We are telling our function it should expect some data passed in for destination that it can apply to any statements in the function body. But how do we actually use this parameter? Our parameter of destination is used by passing in an argument to the function when we call it. Trip welcome times square. This would output, welcome to Trip Academy, looks like you're going to Times Square today. Now if I look up argument in my dictionary, which is an Oxford Dictionary from 1964, which means obviously with some words in a language they have different senses, they refer to different things. However, I believe some of the senses of argument may be more similar than you might think. So let's just read it. So it says reason advanced. So noun. As a noun, argument means reason advanced for, against a proposition or cause. In logic, it's the middle term in a syllogism or reasoning process. An argument could be a debate. An argument could be a summary of subject matter of the book. But that's usually argumentum. Argumentum ad hominem. Argumentum ad hominem means one that takes advantage of character or situation of the particular opponent. Ad erumanum, of his avarice. Ad meaning to in Latin. Ad ignorantium, of his ignorance of the facts. Ex silentio, of his silence. Okay. But the way I like to think of it is when you provide an argument to someone in life, so when people advance reasons, so it might be a barrister advancing a reason for members of the jury to find his client innocent. It might be some scientists who've been working on certain theories about how cancer cells operate, and they write a paper and they're giving you reason to think that their theory is correct by providing lots of data and perhaps some arguments and also some experimental results. In all those cases, what's happening is someone is trying to feed something into the mind of another person to influence the way they think, the manner in which they think. We're not trying to stop someone thinking. We're not trying to, it's the way someone else thinks. So there's some sort of input to another person. And that's the same as what an argument is in Python. The argument is something that you feed in. So, yeah, so the distinction, clearly they're not using parameters and arguments here to mean they're the same thing. The person writing this course is aware that they are two different things. It's not like saying, like some people do, bits and bobs or morality and ethics, where they just trying to cover all their bases by saying two words joined by the word and. No, they mean really parameters and distinctly arguments. So what they mean is the parameter, as they say fairly, the parameter is the thing that you define such that you expect a certain type of thing to be passed in. So if we have the definition and so with trip welcome, and you put destination in rounded brackets, what's happening is we're specifying a parameter. We're not specifying an argument here. That's the kind of just to work the distinction. But when a person is calling the argument and they put something in rounded brackets, now they're providing an argument. I think that's the way they're trying to work it. So the parameter is in the definition, and then the argument is the specific case considered, which has a specific value for that. So when we say Times Square, that's a parameter. So that is the quantity in the case considered, the quantity of the parameter. Okay, let's read. To summarize, here is a quick breakdown of the distinction between a parameter. Oh, here we go. Okay, between a parameter and an argument. The parameter is the name defined in the parenthesis of the function and can be used in the function body. Yep, and there's a little image here. So they've said in the definition line for trip welcome, that's the parameter, the word destination in the rounded brackets. But when we have if we were to have, okay. So they've said destination in this concatenation looks like you're going to plus destination plus today. That mention of destination, now it's oh no, okay, that's still the parameter, yeah, because this is all part of the definition of the function. The arguments is the data meaning information. It's not a generic thing, it's not a form, it's matter. The argument is the Times Square, that's data, right? The argument is the data that is passed in when we call the function, which is then assigned to the parameter name. Take a look at that. So this is now an argument that's being passed in. Let us write a function with parameters and call the function with an argument to see it all in action. Instructions. 1. We want to create a program that allows our users to generate the directions for their upcoming trip. Create a function called generate trip instructions. Let's read. That defines one parameter called location. Note, since we did not define any code in our function yet, we will receive an error in our output terminal. Don't worry, we will be filling in the code in the next step. So generate trip instructions. Let's try and get through this task quickly. You need to have define, so def space, and it just knows that it's a function. You don't need to put the word function anywhere. Def generate trip instructions, and I'm going to put in location. I don't think it needs to be in speech marks. Let's run. Need a colon. Run. We've got a tick. Okay, 2. Generate trip instructions should print out the following. Looks like you are planning a trip to visit location, where location will represent the location parameter. Well, I can do that. So enter, print, speech marks. looks like you are planning a trip to visit, concatenate, plus, and then location. Run. Did you add a print statement? Yes. However, there is a small issue with the formatting of the printed message. To improve readability, add a space after visit. Is that really the problem? Okay. 3. Generate trip instructions should also let our users know they can reach their location using public transit. Let's have generate trip instructions also print out the following on a new line. You can use the public subway system to get to location, where location will represent the location parameter. So print, copy, paste, closing speech mark after a space, concatenate, location, closing speech mark. No. Four. Time for some greenery. Let's see what happens when we call the function and input the argument Central Park, a backyard wonder in the heart of New York City. So call the function. So now I just name the function generate. It's called generate trip instructions. So I'm going to write generate trip instructions. Pass in Central Park as a string value. And it worked. Looks like you're planning a trip to visit Central Park. You can use a public subway system to get to Central Park. 5. The day trip is over and we need to get back to the train station to head home. Change the argument to Grand Central Station and call the function again. What changed in the output? Grand Central Station. Run. Looks like you are planning a trip to visit Grand Central Station. You can use the public system to get to Grand Central Station. Perfect. So we can use functions. Great. Let's end it there.